Hello everyone, Johan Chabot speaking, and I will give today's presentation with Pierre Monin. We are both researchers at Orange, and we are speaking on behalf of the team of the DAGOBAH project. Today's talk presents the result of a collaboration between Orange and Eurecom on the annotation of tabular data. And we will also talk about the industrial challenges behind the use of such annotation tools for the construction of our own enterprise knowledge graph. First question is why it's important to annotate tabular data for a company like Orange. So we are a multi-service company. We are working in network, multimedia, bank, and cybersecurity. And we are also a multi-entity and worldwide company. So large amounts of data are produced every day in different formats by different jobs and in different languages. In the DAGOBAH project, we are focusing on tabular data, but other research teams in our company are working on other media, such as text, for example. Tabular data can power a large number of use cases, and with the DAGOBAH project, we are targeting 3 application areas. The first one is data governance to boost the capabilities of indexing tools with semantics. The second application area is data science, where the objective is to take advantage of semantic annotation to reconcile and enrich data. And we have several subsidiaries that are interested in these capabilities, especially in the field of entertainment. We have to reconcile heterogeneous data catalogs because data producers work with different formats. And also in the field of health, we have issues of enrichment of tabular data with the help of knowledge graph to give practitioners a maximum number of useful information, enabling them to make informed decisions. And the last application area is to make knowledge actionable, which is very important because we have a lot of dormant knowledge that needs to be structured to make it more usable by Q&A engine, for example. And so to exploit this data, a number of challenges have to be overcome, either related to the nature of Orange or to the nature of the data. So we have a few examples in this slide. The first one is that interpreting tables is by nature a complex task, as there is a little context in the tables to disambiguate the values. Another difficulty is a wide footprint of languages with 7 main languages in the Orange group. And finally, we have a wide variety of table structures, as you can see on the bottom of the slide, with often complex layouts, units to be taken into account to interpret the value correctly, or acronyms specific to the company. And so to unlock these use cases and interpret tables efficiently, we use so-called semantic table interpretation techniques with 3 main tasks as defined in the literature. The first one is CEA, to associate each cell of a table with an entity of the target knowledge graph. So we are using mostly Wikidata and DBpedia. Then the CTA is about to type each column with the concept of the knowledge graph. And finally, CPA is to identify properties between table columns. And the resulting annotation help to better understand and index the data. And they can also be used to clean and complete the data for data science, for example. And finally, it allows to discover and structure the knowledge stored in the table. And on this last point, it creates a virtuous loop because the extracted knowledge can enrich the knowledge graph, which is itself used to carry out the annotation. And at Orange, and in collaboration with Eurecom, we have created our own STI system called DAGOBAH.
So let's take a closer look to the DAGOBAH algorithms. First, for the cell entity annotation task, what we do is we compare the text within a cell with the labels of entities in the knowledge graph. Additionally, we enrich this comparison with the context of the cell, which is the other cell of the same row, and the neighborhood entities of the candidate entities in the knowledge graph. Once we have annotated each cell, we perform the columns property annotation task. Here, we choose the most frequently occurring property between entities that annotate 2 columns. Finally, for the column type annotation, there is a majority voting system, which is based on the annotating entities in the same column. However, we also consider the type hierarchy to avoid choosing a too generic or a too specific type. DAGOBAH is a research project that have increasing traction and adoption in the group's business units and countries. Indeed, data owners, data scientists, or data governance managers can use DAGOBAH in a test and learn approach with an API and a user interface. This allows us to get feedbacks from users in a test and learn approach. Additionally, aside from the 3 tasks that I've described before, we also offer some features of table enrichment and knowledge graph visualization. To evaluate DAGOBAH, we participate in a scientific approach offered by the CEMTAB challenge. This challenge is associated with the ISWC conference. DAGOBAH has participated in all the editions of CEMTAB and has been ranked as a top competitive system. However, there is a caveat, as participants often reach some very high F1 score, which poses a question about the representativity of the datasets of the real-world complexities, especially complexities that can be found in tables sitting in company repositories. For example, tables may not be so homogeneously shaped, and the artificial generated noise may not be enough with regard to real-world complexities, such as multivalued cells or different units involved in the same columns. Finally, the target knowledge graphs are mostly encyclopedic. However, in company repositories, tables may involve specific vocabularies, for example, vocabularies related to networks or other domain activities. Hence, there is a need to develop advanced datasets offering more difficulties, such as matrix tables or multivalued cells, and involving different business domain vocabularies. To conclude, there are several perspectives to our work. First, as a research perspective, we are investigating how embeddings can help table annotation. Indeed, we believe that geometric properties of vector spaces can help to cluster candidates. Even if this approach is computationally expensive, it offers promising results, especially on highly ambiguous tables. As aforementioned, we also participate in the development of additional benchmark datasets that involve additional complexities, such as multivalued cells or business domain vocabularies. In this view, there is also an industrial challenge, as we may need inside Orange to annotate datasets that involve Orange business knowledge. And in this case, Wikidata may not be enough. Hence, there is a need to develop an Orange-specific knowledge graphs, for which the semantic table interpretation task may help. Indeed, with the extracted knowledge, we can bootstrap and enrich the specific Orange knowledge graph. So that's it for our talk, and thank you for your attention.